So now let's start to talk about some examples related with integration by parts. Okay, and the co-formula for the integration by parts, which is u times v prime dx equals u times v minus u prime times v du. Okay, so this is going to be the key. Okay, so maybe we can start with one example here. If I have x cosine x dx here. Okay, cosine x dx here. Now, as you can see, when you make a selection, your u and v prime, you do have two choices. There is one. You can do that u equals x, that v prime equals cosine x. Okay, and correspondingly, u prime gonna be 1, v gonna be sine of x. So we know that. Okay, you can make another option 2. That is, you can set your u is equal to cosine x. Okay, your v prime is x. Then under this situation, u prime gonna be negative sine x, and v gonna be x squared over 2. Okay, we don't know which one is better in the very beginning, but after we apply the integration by parts formula, we can tell immediately. Okay, so if I let me draw this way. If I apply the integration by parts for the first part, so if my u and v prime is like this, so I'm gonna have u times v, which is x times sine of x, okay, minus integral, it's u prime times v, which is 1 times cosine x dx. Okay, all right. Now we do the same thing for the second one, which you're gonna have, it's u times v, which is x squared over 2 times cosine x. Okay, minus, well, it's going to be minus sine x times x squared over 2 dx. Okay, so now things become very obvious. Why? Because on the left, this integral, it is very easy to evaluate it, because it's just the integral of cosine x, which is going to give us is sine x. That is very easy to handle. Okay, to handle. Oops, I think I made a mistake. This should be sine x here. Okay, this is sine x. Right, because it's u prime times v. Okay, so this integral is very easy to handle, because it's just a negative cosine x. So it turns out x times sine x minus the integral of this is negative cosine x, and don't forget the constancy. So our result for this problem is x times sine x plus cosine x plus c. Okay, so that's our answer. But now let's go back to take a look at with this one. You can see that this integral, it's not trivial. In other words, it's not very easy to evaluate. More than that, you can see that before it was x times cosine x here. If you make this selection, it's a trick, negative sine times x squared over 2. So the order of the monomial inside of this integral, before it was 1, but after you do this, it becomes a 2. Okay, while if we make the choice 1, you can see that the order of the monomial here, it becomes into 0, because you can treat 1 as x to the power of 0. So 1 is reduce the order, 1 is increase the order. So which one is better? Apparently, number 1 is a winner. Okay. So this is the the first example. Now, maybe let's move on to introduce another problems here, so you can take a careful look about this integral things. Okay, so now so if we take this as example 1, and then let's do the example 2 here. Still, we're going to apply the integration by parts. So the problem is x squared ex dx here. Okay. So again, you have two choices. You can set u equals x squared, then u prime is 2x, and v prime is e to the power x, and then v is still e to the power x. Okay. So that's to be consistent. You can make another choice, is set your u equals e to the power x, v prime equals x squared, corresponding to u prime, it's ex, v is x cubed over 3. So by showing this, I just want to let you know that when you are starting to work on the problem with integration by parts, you do have to be very careful about your selection. Which one is u, which one is v prime. Okay, so now follow the same procedure. Let's formulate. So if I apply the integration by parts formula, u times v is going to be x squared times e to the power of x minus, or u prime times v, which is 2x times e to the power of x dx. Okay. While if we follow this, it's going to be u times v, which is x cubed over 3 times e to the power of x, minus u times v here, u prime times v, which is x cubed over 3 times e to the power of x dx. So now let's do another round of comparison. As you can see that in my original integral, I have x squared e to the power of dx. And following the first selection, you can see that the integral on the right hand side, it becomes into a monomial with order 1 times e to the power of x. While for following this way, the integral I formulated, the order before it was 2, right now it becomes into 3. It increases the order. Okay, so in other words, the integral I formulated here, it becomes more complex than my original one. So apparently, still, number 1 is a winner. Okay, number 1 is a winner. However, for this problem, we're not done yet, because if you look at this integral here, we're gonna use the integration by parts again. Okay, so if we set, so this is everything about, so if we set my new u equals 2x, my v prime equals e to the power of x, and u prime gonna be 2, v gonna be still e to the power of x. So follow that, we have x squared times e to the power of x minus, I'm gonna use a bracket, okay, because I use the integration by parts twice, okay, twice. And so u times v, which is 2x times e to the power of x, okay, minus integral, which is u prime times v, which is 2 e to the power of x dx here. Okay, so that is what I got. So it turns out this integral is very easy to compute. This is just a 2e to the power of x. Okay, so it turns out this is going to be x squared times ex minus 2x ex. Minus minus become plus, is 2ex, and then plus a constant c. And if you can rewrite it nicely, factor this e to the power of x out, that is x squared minus 2x plus 2, and then plus constant c. That finishes the problem. Okay, so in this short video, we discussed two examples about the integration by parts and about how you select your u and v prime, and after, like we talked about, after you apply this integration by parts, and that integral you formulate on the right hand side should tell everything. Okay, whether it's an easy one or it's a more complicated one, and then you can, based on the easy one, to finish the problem. Okay, and this kind of idea works for all the skills, techniques, theorems, principles in mathematics, because the goal for all these methods is to help us simplify the problem, not complex our original problem. Okay, so hope you enjoy this video.